So on our first one here, we have sodium chloride, which is an ionic compound, and it's reacting with calcium oxide, also an ionic compound. What kind of reaction are we looking at? Double replacement reaction. Okay? In a double replacement reaction, the pattern is that very simply the metals are going to switch partners with each other. So that means sodium is going to end up with oxygen on the other side, and calcium is going to end up with chlorine on the other side. Okay, so now I've identified the reaction type, I've reviewed the pattern, and used the pattern to figure out who goes with who. I just made two ionic compounds. What do I have to do with both of them?
Drop and swap.
Exactly, got to drop and swap. Okay, so this is a -2, this is a +1. So we drop and swap. We're going to have Na2O. All right, and then for calcium chloride, chlorine's always a -1, calcium's a +2, so we'll have CaCl2. Okay, other thing I have to do, I got to check for special elements. I don't have any. Everything in this reaction is a compound, so I don't have to worry about that. Right? What's the last thing I have to do?
Balance.
Yeah. Okay. So in this one, because it's not a combustion reaction, I just go with the biggest number, and the biggest number is 2. Okay? And there are two things with a number 2 on them, right? And they both have the same charge. One's a +1, one's a -1, so it doesn't matter which one I pick. Okay? I'm going to balance the sodiums first. So there's 2 sodiums on this side. Okay? What do I need to put in front of this?
2.
Yep. Okay, when I do that, does it also give me 2 chlorines on this side?
Yes.
It does, okay. And there's 2 chlorines on that side, so now I've balanced 2 things. Okay, 1 calcium right here, 1 calcium right here, so it's also balanced. 1 oxygen, it's balanced, the reaction is balanced. Okay, always just kind of double check. Go back and forth just to double check that everything actually works out. All right, those are your steps, guys. Doesn't matter what kind of reaction it is, okay? The steps for predicting are identify the reaction type, okay? Review the pattern, use the pattern to match up the products, check for special elements, drop and swap ionic compounds, balance the reaction, okay? It's always the same set of steps that you want to walk through when you're doing this. Okay, I'll give you a few more minutes to get ahead of me and we'll do a couple more. All right, guys, let's have a look at number 2 here. So in number 2, I've got iron 3 bromide, okay, and it's reacting with sulfur. So I've got an ionic compound and it's reacting with an element. In this case, the element is a non-metal. Okay, so what kind of reaction would I be looking at there? Single replacement, yeah. Okay, in a single replacement, the pattern is that this element has to replace the part of the ionic compound that it is like. Since sulfur is a non-metal, that means it's going to swap out the non-metal. So sulfur and bromine are going to switch places. So that's meaning I'm going to have iron with sulfur and bromine by itself. Okay, so now I've used the pattern to figure out who goes with who and who winds up alone on the product side. Now I've got to check for special elements. Do I have any? Yeah. Bromine is special, comes as a 2. Okay. And I've got to drop and swap ionic compounds. Okay, I do have one of those. Now, iron is multivalent. It can be a 2+ or a 3+. And in this case, I've got to figure out which one it is, so I drop and swap correctly. So what I do is I go back to the reactant side. Okay? Iron is with bromine here. Bromine has a charge of -1, and there are 3 bromines. So there are 3 negative charges in this compound. So that means there have to be 3 positive charges. And there's only 1 iron to get them from, so this is the iron with the 3+ charge. So now I can come over here and do my drop and swap. Iron's a 3+, sulfur's a 2-, Fe2S3. Okay, so when it comes right down to it, guys, single replacement reactions have the most to do. Okay, you're going to make an ionic compound, so you're going to have to swap and drop. There is a high likelihood you will produce a special element that you will have to check. Okay, not always, but in high likelihood. right? And then you're gonna sometimes, in a single replacement reaction, have to do what we did and figure out the charge on a multivalent metal, right? So there's lots and lots of stuff to do typically in a single replacement reaction. All right, what's my last step? Balance the whole reaction. Okay, biggest number is 8. Yeah, okay? I mean, it's a 3 over here, but it's an 8 here. All right, so I've got 8 on this side, and I've got 3 sulfur on the other side. What's the lowest common multiple of 8 and 3? 24, I think, yeah. 8 and 2 would be 16. 8 and 3 is 24. Okay, 8 times 3 is 24. All right, so I'm going to have to put an 8 here and a 3 here. So there's going to be some big balancing numbers on this one. Okay, and really, anytime sulfur's involved, there's a good chance of that because it's always going to come as an 8. Okay, all right, so now I've put this 8 here. How many iron does that mean I have?
16.
Yeah, so I got to put a 16 in front of this one. All right, now how many bromine does that give me? 16 times 3 is 48. What times 2 is 48? 24. Yeah. So I got to put a 24 there. Okay. Now, would I give you one on a test that would have numbers that big? Probably not. Okay. But it's possible you can get one. Right. These are going to be sometimes big numbers when you have sulfur involved. Okay. Everybody all right with that? Okay. How many people have done number 3? Okay, let's have a look at number 3 as well then. All right, so in number 3, okay, what kind of reaction is that if I've got a hydrocarbon and oxygen?
Combustion.
Combustion reaction, right? What are always the products of a combustion reaction? And water, right? And in a combustion reaction, I should write water this way. Okay? In a replacement reaction, I'd probably want to write it HOH, but here H2O is better. Okay, do I need both special balancing rules here? Yes, I do. 8's an even number, so I need to start with the rule of 2 by putting a 2 at the beginning. Now I've got to balance in what order? Alphabetical order. Okay, what's 2 times 8? 16. All right, so I've got 16 carbons here, so I've got to have 16 carbons on that side. All right, for my hydrogens next in line alphabetically, 2 times 18 is 36, I believe. Okay, so what needs to go here? Have you guys noticed this pattern yet? 18, yeah, it's always whatever this number is has to go over here. If you put a 2 here, 2 times 18 is 36. If there's a 2 here, 18 times 2 is 36. It's always going to be the same number. Okay. All right, and then, okay, I've got to do my oxygens. I can't start here because I don't know how many there are here, but I do know how many there are on the product side. I know that there are 18 of them here. Okay, and I know there are 16 times 2. So 32 of them here. 32 plus 18 is 50. All right, so what needs to go in front of O2? 25, yeah. Okay, it's possible you could get combustion reactions with big numbers. There's not really a way to avoid that. If you're starting out with a 2 here, you're automatically going to be into bigger numbers. Okay, but you can have a calculator on your test if you want. Okay, when we do mole equation stuff, you're going to need it, but if you want it to help you out with the balancing, that's fine. I got no problem with that. All right, I'm going to put a couple more up here. You guys keep going. I'll do a couple more in a few minutes. Okay, so number 4, I've got beryllium reacting with fluorine. So 2 elements reacting with each other. What kind of reaction would that be? Synthesis, yeah. Okay, so in a synthesis reaction, all that happens is these 2 things combine, right? They're going to combine to form a single compound. So I'm just going to write them together. BEF. All right, so identify the reaction type. I've used the pattern to figure out who goes with who. Okay, what kind of compound did I make there? I made an ionic compound, right? In any synthesis reaction, I'm going to have you build an ionic compound. Here's why. It's the only one that you can actually drop and swap to figure out the right numbers. If you build a molecular compound, there's any number of combinations that those two non-metals can go together in because they share their electrons. They don't trade them. Okay, so it's always going to be an ionic compound. All right, so we got BEF, okay, and that's going to be beryllium fluoride. So since it's ionic, I have to drop and swap. Fluorine's always a -1. Beryllium's always a +2. I feel the balancing will be easy with this one. Okay, like it might already be done. Right, 1 beryllium on both sides, 2 fluorines on both sides. Sometimes it's just that easy. Okay. Everybody all right with that one? Okay. Number 5, we have only one reactant, chromium-3 nitride. Okay, what's it going to do? It's going to decompose, right? It's a decomposition reaction. If you only have one reactant, that's all it can do. It can't react with itself. Okay, so all it can do is decompose or break down into its 2 elements. Okay, what do I need to check for here? Special elements, right? So a very high likelihood in a decomposition reaction you're going to make special elements. Chromium's not special, okay, but nitrogen is. It comes as a 2. Right. All right. I don't have any ionic compounds, so I don't have to worry about that. What do I have to do now? Balance the reaction. Yeah. Okay. There's 2 nitrogens over here. How many are there here? Just 1. So what needs to go here?
2.
Okay. But that gives me 2 chromium. So what needs to go here?
2.
A 2. And now it's balanced. Okay. All right. Keep her going. I'll give you a couple more minutes and I'll do a couple more. Guys, if you're having trouble or you want some help, just let me know. Okay. I'll come around and give you a hand. Oh, yeah, actually, that's the reason I put that one on there. Okay, let's just address this right now, guys, because it did come up and it's the whole reason I put it on here. In number 9, what kind of reaction is that? It's a synthesis reaction. Okay, so it's a synthesis reaction and it's going to form an ionic compound on this side, nickel with phosphorus. Okay, the question here is, nickel has more than one charge. How am I supposed to know which one to use if when it started, it wasn't in a compound? It has to be in a compound for me to figure out what its charge is. Here it's an element, it doesn't have a charge. So how do I know which one to use? The answer is simple. You go with the first one. These are always listed in their order of occurrence or popularity, let's say. Okay. Usually, even if something has more than one charge, 90-some% of it will be this one, and a very small percent of it will be the other. Okay. So if you have no way to figure out which one it is, like in number 9, you go with the first one listed. Okay. So in this case, this would be the nickel with the 2+ charge. Okay, so Ni2+, phosphorus is always a -3, drop and swap. Ni3P2. Okay, everybody with me there? It's just one of those little things. It doesn't come up that often, but you need to know what to do when it does come up. Okay, let's balance this one real quick here, guys. What should I start with? Phosphorus. It comes as a 4 on this side, so what needs to go in front of this? 2. Okay, how many nickel does that give me? And we're done. Okay. All right, keep going. You got a freebie there. All right, so for number 6, I've got barium phosphate. That 4 should be small, but for whatever reason it's not. Okay, plus CuSO4, so copper 2 sulfate. Both ionic compounds. What kind of reaction are we looking at? Double replacement reaction. Okay, pattern for double replacement, swap the metals partners. All right, so that means that copper will end up with phosphate, okay, and barium will end up with sulfate. Okay, so now I figured out who goes with who. Did I make 2 ionic compounds? double replacement reaction. All we can have are ionic compounds. So I've got to drop and swap both of these. All right. Barium's always a +2, right? Yeah, it's always a +2. Okay, so this one I can drop and swap right now. This is a +2, this is a -2, so that compound's fine the way I wrote it. Okay, if I want, I could put brackets around it. Okay. Copper, on the other hand, can be a 1 or a 2. Right, so I've got to figure out which one it is over here on the reactant side. Sulfate's always a -2. Okay, and there's 1 sulfate here, right? Because if it was in brackets, there's no number, so it's a 1. Okay, so there's 2 negative charges in total. That means I've got to get 2 positive charges from 1 copper. 2 divided by 1 is 2, so this is the copper that is 2+. Okay, phosphate is always 3-. So drop and swap. And we'll be looking at that. Okay, it's a bit of work on that one. What do I do now? Balance the reaction. Biggest number is 3. Yeah. So let's start with barium just because it's the first 3. Okay, they have the same charge, so it doesn't matter which one I pick. So there's 3 barium over here. How many here? Just 1. Okay, so I'm going to put a 3 in front of that. Now that gives me how many sulfates? 3. Okay, so I got to go back over here. How many sulfates are there here?
1.
Just 1. So what needs to go in front of this? A 3. Okay, now there's 3 sulfates, 3 there and 3 there on both sides. Look what that did to my copper. 3 coppers here and 3 over there. Always a good sign when that happens. It means you're on the right track. Okay, so let's just double check everything. I've got 2 phosphates, 2 phosphates, 3 copper, 3 copper, 3 sulfate, 3 sulfate, 3 barium, 3 barium. Yep, it's balanced. Okay, that's about as involved as a double replacement reaction gets. All right, questions on number 6? All right. What kind of reaction is number 7? Decomposition. It's only got 1 reactant, so it's going to break down into its 2 elements. Okay, so what do I need to check for? Special elements. Are there any?
Yes.
Okay, and now I need to balance this. Okay, so this is one of the ones, like that's that small percentage where the biggest number doesn't work the first time. Right? Biggest number in this reaction is 3. So if I just go over here and go, sweet, 3, now that's balanced. Now I look at the nitrogens and go, oh, wait, that's not going to work because I can't balance the nitrogens with that 3. So that's fine, that happens sometimes. I just erase it and I start over again with the nitrogen. Now my nitrogens are balanced. How many lithium does that give me? 6. Okay, so I'll just put a 6 there. Now it's good. Okay. It happens once in a while. Okay, it's a good rule. Works most of the time. Okay. All right. How many people have done number 8? Okay, let's look at 8 as well. Then. What kind of reaction is 8? Combustion reaction. We got a hydrocarbon reacting with oxygen. Products are always the same 2 things. CO2 and water. Right. All right. So I've got those 2 products there, and special balancing rules are balance alphabetically and the rule of 2. Do I need them both? I only need rule number 1. Okay, 9 is an odd number. I only need the rule of 2 if I have an even number. All right, I've got 9 carbons here. So what needs to go here? 9, yeah. I've got 20 hydrogens here. What needs to go here?
20.
Yeah. And now I can balance my oxygens. 9 times 2 is 18, plus 10 more is 28. Pretty sure 14 times 2 is 28. Okay. Questions on that? Are these starting to feel a little familiar? Okay, guys, there's no like magic trick to learning how to do predicting and reactions, except practice. Okay, the only way you'll get good at these is if you practice, practice, practice. That's why we're spending so much class time on it. okay? But you may need to spend time on this outside of class, okay? It's why there are so many worksheets that we'll absolutely never get through, okay, in the workbook, right? So that you can practice more on your own, okay? Everybody with me there? All right, how many people are done 10? Okay, let's look at 10 and then I'll give you a little break. All right, so on number 10 here, I've got zinc hydroxide ionic compound, and it's reacting with potassium, which is an element. In particular, it is a metal. What kind of reaction am I looking at?
Single replacement.
Yep, single replacement reaction, okay? Ionic compound reacts with an element. So, according to the pattern, in a single replacement reaction, okay, the element replaces the part of the ionic compound it's like. So a metal has to swap out a metal. That means potassium ends up with hydroxide, and zinc winds up by itself. Okay. Do I have any special elements? Okay, zinc's not special. Okay, do I have any ionic compounds? Okay, so I gotta drop and swap those. That's a -1, that's a +1, so that compound is okay. The way I wrote it, KOH. Now what do I do? Balance. Okay, so biggest number is 2, and it's on the hydroxide. So there are 2 hydroxides here. What needs to go here?
2.
Okay, that gives me 2 potassiums, so what needs to go here?
2.
And we're done. Okay? All right. Okay, here's what I would like you to do. Somewhere in your notes, I want you to copy down these steps, okay, for predicting the products of a reaction. Reaction, RXM, shorthand for reaction. So the first thing you want to do is identify the reaction type, okay? Then use the pattern to predict the products. Drop and swap any ionic compounds on the product side, okay? Identify any special elements and write the proper number. And then the last step is, of course, to balance the reaction, okay? Okay, so now I'm giving you the reactants in words, which means you've got to write the formulas to start, okay? Yes, that's a little more challenging, but I'm supremely confident that you can handle it, or I wouldn't give it to you. Okay. All right, so if you're doing these, the steps don't really change except that you weren't given the reactants as formulas, you were given them as words. So we write the reactants first. Okay, dicarbon, how many carbons is that?
2.
Okay, how many is hexahydride?
6.
6. Okay, burns in oxygen gas. That makes it really easy. It tells us what reaction type. What's burning mean? Yeah, combustion, right? Okay, so, all right, I know that this is a combustion reaction. Now, from here, it's just like all the ones we've done before. You have the reactants, now make the products. Okay, products of a combustion reaction are always the same 2 things. Okay, carbon dioxide and water. Do I need both balancing rules for this one?
Yes.
Yeah, I do. Okay, so I'm going to start with a 2. Okay, and then start with carbon. 2 times 2 is 4. So I'll put a 4 over here. 2 times 6 hydrogens is 12. So 6 times 2 hydrogens is 12. And then I'll look at my oxygens. 4 times 2 is 8. Plus 6 times 1 is 6. So that's 14. 7 times 2 is 14. Okay, doesn't really change anything. You just have to write the formulas for the reactants if I give it to you in words. Otherwise, it's exactly the same as what we were doing before. Okay, give you a few minutes on those. Okay, let's look at number 2 here. So I've got sodium nitrate. Is that ionic or molecular? It's ionic. Sodium's a metal, right? Okay, so I'm going to go, all right, sodium is a +1. Nitrate is a polyatomic ion, NO3, and it has a charge of -1. Okay, so that compound is already dropped and swapped, okay, the way I wrote it. Okay, so I'm good there. I can put brackets around the nitrate if I want. Okay, and it reacts with magnesium. Magnesium's just by itself. All right, what reaction type does that look like? Single replacement, yeah. We've got an ionic compound reacting with an element. In this case, that element is a metal, right? So the pattern says that this metal has to swap out the metal in the ionic compound. So that means magnesium ends up with nitrate, okay, and sodium winds up alone. Okay, since it's a single replacement reaction, I need to check for both special elements, there aren't any, okay, and I have to drop and swap the ionic compound I just built. All right, so nitrate we already know is a -1, but magnesium is a +2. So I've got to drop the 2 over here, the 1 would go there, we don't write those. Okay, now I've got my drops and swaps. Can I balance? Should be able to balance now, right? I don't think I've forgotten anything. Okay, what's my biggest number? 2. Okay, there are 2 nitrates right here. Okay, but there's only 1 on this side, so this needs a. That gives me 2 sodiums. So what needs to go here?
2.
Yep, and then I think everything's balanced, right? There's 1 magnesium, so everything else is balanced. Okay, so like I said, it doesn't change what you do. You just have to write the formulas for the reactants now. Okay, you guys are fine at that. Okay, you guys know how to make formulas. That's all you're really doing, is you're just writing the formulas for whatever the reactants are. And you guys are fine at that. So, okay, not too tricky. How many people have done number 3? Okay, so magnesium nitride breaks down. So Mg with N. That's an ionic compound. 2 plus, 3 minus, Mg3, N2. Breaks down. What does that mean for a reaction type? It's decomposition. There's no other reactant, right? That's just what there is. So it's a decomposition reaction. That means magnesium by itself, nitrogen by itself. Okay, no ionic compounds to drop and swap in the products, but there are.
Special elements.
Right. Nitrogen is a 2. All right, now we got to balance. Nitrogen's good. What needs to go in front of the magnesium?
3.
Okay. How many people have done 4? Okay, let's look at 4 and then I'll put a couple more up there. Okay, number 4. So sodium permanganate reacts with iron 2 sulfide. Okay, sodium, okay, +1. Permanganate, MnO4, okay, one of our polyatomic ions. And it reacts with, and sorry, this is a -1, so that compound is okay, the way I wrote it. Can put brackets around that if I want. Okay, iron 2, so that's the iron with the 2 plus, sulfide, S. Okay, here's the good news about this. I don't have to figure out the charge when it's given to me in words, because they tell it to me with the Roman numerals. So that part's a little easier. Okay. All right, so this is a 2 plus, this is a 2 minus, so that compound's fine the way I wrote it. What kind of reaction are we looking at? Double replacement. They're both ionic compounds. So we're going to swap the metals because that's what the pattern says to do. So that means iron ends up with permanganate. Okay, this iron is a 2 plus, permanganate's a -1. So we'll have to write it like that. And sodium is going to end up with sulfur. Sodium's a +1, sulfur's a -2, so end up with that. Okay, so I've identified the type, I've used the pattern, I dropped and swapped my products. What's left?
Balance.
Balance the reaction. Okay, biggest number is 2, and it's on both permanganate and sulfur, which both have a charge of 1. One's negative, one's positive, but it's 1. Okay, so I'll just start with permanganate. I only have 1 on this side, but there are 2 over there, so what goes here?
2.
That balances my sulfur, and I think everything else as well, right? 2 sulfurs, 1 iron, 1 iron, 1 sulfur, 1 sulfur. Okay, we're good. Sorry, I said sulfur, I meant sodium. Okay, how are we feeling about that? Okay, like I say, it's just a matter of practice. It's why we take so much time. And I know you're going to be bored to tears doing this for the next couple of days, but, okay, you'll thank me when you're on the unit exam and you're just rocking it because you know how to do it. Okay. All right. Okay, I think I've got 10 there, yeah. All right, try those. Okay. So with number 5, we did one like this on the previous list, okay, where we got a multivalent metal, but when we started the reaction, it was by itself, okay, and it's reacting with fluorine gas. That's this, all right. So what kind of reaction am I looking at there? It's a synthesis reaction. So I've got to put them together in a compound. Problem is, copper's got more than one possible charge, and there's no way for me to calculate it from the reactants. So I just have to go with the two, the first one, the most common charge. Okay, whatever one is listed first is the most common charge. Okay, so I go with that. Cu is the 2 plus, fluorine is the 1 minus, CuF2. Okay. And the reaction's balanced. Okay, so again, it doesn't come up very often. We've seen it twice, okay, in what, like 20 reactions. So it doesn't happen very often. All right, for number 6, we've got hydrogen sulfate. Okay, hydrogen's listed first, so behaving as a metal, with sulfate, SO4 minus 2 charge. Okay, what? Oh, it's contagious, you know. Other people will do it. Okay, so what we've got here, guys, is we got a drop and swap. So we'll have H2SO4. Like that, we can enclose the sulfate in brackets if we want to. Right? It reacts with magnesium hydroxide. Mg, 2 plus, with hydroxide, OH. And that's a -1. So when I drop and swap, that one's going to need brackets like that. All right, what kind of reaction am I looking at there? It's a double replacement reaction. So I got to swap the metals. That's what the pattern says to do. So magnesium will end up with sulfate, and hydrogen will end up with hydroxide. And I'm going to write it like this. Okay, in other words, water. So did I just make 2 ionic compounds? What do I need to do with both? Drop and swap. Okay, the water's fine. This one's -1, this one's +1, so we're good there. This one is a -2, okay? This one is a +2, so we're also good there. We don't have to do anything with that. I can put brackets around those if I want. All right, now I've got a balance. Biggest number in this is 2. Okay, there are 2 hydroxides and there are 2 hydrogens. They both have a charge of 1, so it doesn't matter which one I start with. So I'll start with hydrogen, and I'll put a 2 here. Do I need to do anything else? Pretty sure that balances the rest of the reaction, right? I got 2 hydrogens, 2 hydrogens, 2 hydroxides, 2 hydroxides, 1 magnesium, 1 magnesium, 1 sulfate, 1 sulfate. Yep, it's definitely balanced. Okay, did that answer your question? No. All right, keep going there, guys. See if we can finish these up before class ends. All right, let's look at 7 and 8 here. So on number 7, we got tetraphosphorus pentaoxide. What kind of compound are we looking at here? It's molecular, right? It's got all these prefixes in it. We don't encounter a lot of those when we're doing reactions. Okay, so tetraphosphorus means there's 4 of them. Pentaoxide means there's 5 of those. And it's breaking down. So what kind of reaction is it? Decomposition reaction. All right, so in this decomposition reaction, we're going to get phosphorus and oxygen by themselves. I need to check for special elements. Do I have any? Yes. They're both special. Okay, phosphorus, more special than oxygen. Okay, what's my biggest number in this reaction? 5. Yeah, I got to start with that. There are 5 oxygens here and 2 over there. What's the lowest common multiple of 2 and 5? 10. Okay, so 2 times 5 is 10, and 5 times 2 is 10. Oh, look at that. 2 times 4 is how many? Okay, and a 2 there. Same number, right? All right, everybody okay with that? Yes. Okay, So not terribly difficult. You did have to do a little bit of the what's the lowest common multiple math, but I mean, it's not terribly taxing. All right, let's look at number 8. So tin reacts with beryllium nitride. So tin is by itself, just an element, Sn. And it's reacting with beryllium nitride, Be 2 plus, nitrogen 3 minus. All right, I got to drop and swap that ionic compound, so Be3N2. What kind of reaction is this?
Single replacement.
Single replacement reaction. I have an element reacting with an ionic compound. In this case, the element is a metal, so we're swapping the metals here. All right, so that means beryllium winds up by itself, and tin ends up with nitrogen. Okay, is beryllium special? No, it's not. Okay, beryllium's not special. Okay, I've got tin and nitrogen together. That's an ionic compound, but I got a problem. Tin has more than one possible charge. And it was an element in the reactants, so I don't know what its charge is, so I just go with, right, most common charge, 4 plus. Okay? So Sn plus 4, nitrogen 3 minus, drop and swap. Sn3 and 4. All right, now I got to balance this mess. Okay, biggest number is 4. Okay, and that's on the nitrogen, so what needs to go here? How many beryllium does that give me?
6.
Okay, and I've got 3 tin over there, so what needs to go here? Looks to be balanced to me. Okay. All right, we'll leave it there for today. So tomorrow, I won't be here. Okay, Mr. Van Erb will be here. Mr. Van Erb is like the greatest sub who's ever lived. Okay, here's the really good news about him, besides the fact he's the greatest sub ever lived. Okay, he's old, and he's been teaching Science 10 for like 35-ish more years. Okay, so if you have questions, you can ask him, and he can help you because he knows this stuff even better than me. Because believe it or not, he's even older than me. Okay, so you can totally ask him questions. It makes him happy. Okay, if he gets to come around and help people, that's his shtick. So, okay, make him happy, ask him questions, he'll come around and give you help. Okay, no problem at all. All right, remember, quiz on Friday. Okay, reactions, naming, solubility. There won't be any, I don't think I put any predicting on that one.